Today we are going to start here the next concept, that is the dispersion of light. So what is the dispersion of light? Very simple. Now dispersion of light, the process in which the process in which here the separation of light into its components color. What is the dispersion of light? Very simple concept. The process of, that is the process of separation of light into its components color while passing through a medium is called the dispersion of light. What is dispersion of light? The process of the separation of light into its components color while passing through a medium is called the dispersion of light. Very simple. Now, Sir Isaac Newton was a first person to use the glass prism and to obtain here the sun, that is the sun spectrum. Very simple. Sir Isaac Newton is a well-known personality. He is a scientist. He was a scientist. During that time, he used here the glass prism to obtain here a spectrum, that is the sun spectrum. And now there are, and if the rays of light, that is the incident rays of light, enter in a glass prism, to obtain here the separations of seven color, at least the different color formed, and such a colors having a bends, and that is the difference angle. Means incident rays of light fall on a glass prism, the spectrum formation of spectrum, and having a different angle. Now today, at least you know here, the red color at least, that is the angle bends at least, and the violet colors bend at most. Now there are here a glass prism, there is a glass prism. This is the sunlight. Those sunlights enter in glass prism. What happened here? There are the formation of seven color. Red color, the angle, that is the bends, means at least red colors bends, and at most violet colors bend. That is the spectrums of seven color: red, orange, yellow, green, blue, indigo, and violet. It is called as the spectrum of that is the sunlight. Means formation of light enter in, that is the incident rays of light enter in medium, for example glass. What happened here? They split in the seventh color. It is called as the spectrum of light. Consists of red to orange, red to violet, red first. They bend at least different angles. They bend in different angles because the wavelength of seven color are also different. That's why here red and violet color are a different angle. At least red color and violet color has the most angle. That's why here, and light is the electromagnetic radiation. Wavelength is an important properties of radiation. Now here red color and look here, red color and violet color, red color and violet color. Red color, the angle of red color, that is, look here, the red colors has the maximum wavelength close to 700 nanometer, and very simple, the violet color have 400 nanometer. 400 nanometer means red color, that is the angle of deviation for red color is least, and angle of deviation for violet color is here the most. But wavelength is the main important property of radiations, and that's why here red color in its wavelength 700 nanometer, and violet color its wavelength 400 nanometer. But 1 nanometer is equal to how much? 1 nanometer is equal to 10 raised to minus 9 meter. 10 raised to minus 9 meter. Look here, wavelength is an important property of the radiation. Because the frequency is also an important property. Suppose if the rays of light in vacuum, that is the sunlight, the velocity of light in vacuum, and also same it's the frequency, and also the different color have also a different frequencies. That is, if the rays of light enter in glass prism, what happen here? At that time, this formation of seven color, it is called the spectrum of light. Red color, orange, yellow, green, blue, indigo, and violet. All these are the spectrum of seven color. Glass prism, Sir Isaac Newton was a first person to use the glass prism to obtain here it is called as to obtain here the spectrums of light. Now today या पाठामध्ये आपण प्रकाशाचे अपस्करण याचा अभ्यास करत असताना इथे ग्लास प्रिझम घेतलेला आहे आणि या प्रिझम मधून जेव्हा हे प्रकाश किरण ज्याला आपाती किरण प्रवेश करतात तेव्हा त्याच्या 7 रंगामध्ये पंक्ती तयार किती 7 रंगामध्ये याला स्पेक्ट्रम ऑफ लाईट असं म्हटलंय. सगळ्यात वर जो आहे तो लाल रंग ज्याला आपण तांबडा म्हणतो आणि सर्वात कमी सगळ्यात शेवटी जो आहे तो व्हायलेट म्हणजे ॲटलिस्ट म्हणजे कमी जो ज्याला कोन म्हणतो आपण तो रेड रंग आहे आणि व्हायलेट्स जांभळा जो आहे तो सगळ्यात जास्त डेव्हिएशन्स अँगलचं त्याचं इथं आपल्याला पाहायला मिळेल. मग वेवलेंथ इज अन मेन इम्पॉर्टन्स प्रॉपर्टी. हे काय वेवलेंथ त्याला तरंगदैर्घ्य हे रेडिएशन्स जे आहेत लाईट इज इलेक्ट्रोमॅग्नेटिक रेडिएशन. वेवलेंथ इज मेन इम्पॉर्टंट प्रॉपर्टी ऑफ हिअर द लाईट. दॅट्स वाय हे रेड कलर बघा तांबड्या रंगाचे तरंगलहरी 700 नॅनोमीटर इज युज्ड टू मेजर इज युज्ड दॅट इज अन युनिट नॅनोमीटर अन युनिट टू युज्ड द मेजरमेंट ऑफ वेवलेंथ. हे बघा नॅनोमीटर जे आहे हे एकक कशासाठी वापरलं जातं तर तरंगलहरीसाठी वापरलं जातं. म्हणजे लाल रंगाची तरंगलहरी किती आहे त्याचं मेजरमेंट जे आहे ते 700 नॅनोमीटर आणि व्हायलेट रंग जे आहे त्याचं 400 नॅनोमीटर. बट 1 नॅनोमीटर इज इक्वल टू हाऊ मच 10⁻⁹ मीटर. बघा तुम्ही लाल रंग जो आहे आणि हा लाल रंग प्रामुख्याने डेंजरस जिथं आहे ज्याला धोके जिथं आहे तिथं आपण सिग्नल म्हणून वापरतो. जिथं ज्या ठिकाणी ऑपरेशन थिएटर असेल त्याच्या बाहेर लाल रंग आहे लाल रंग वापरतात किंवा एखादा टॉवर्स आहे त्या ठिकाणी लाल कलर्स इंडिकेशन दर्शवतात. सिग्नल आहे तिथं रेड कलर दाखवतात. का? बिकॉज द वेवलेंथ ऑफ रेड कलर इज मॅक्सिमम दॅट इज द 700 नॅनोमीटर ॲज कम्पेअर टू व्हायलेट कलर. Its wavelength 400 nanometer. That's why the red color is used as the indication for the different purpose. Now today, next point, the formation of rainbow production. Rainbow productions, rainbow is here the process of, that is the beautiful phenomenon. And those beautiful phenomenon which consist of dispersion, refraction, and total internal reflection of light. If the rays of light, that is the sunlight, look here, this is the droplet, water droplet. Droplet is a small prism, small prism, which act as a small prism. If the rays of lights enter in that droplet, what happens here? Dispersion, look here, dispersion. Second, refraction, and total internal reflection of light takes place. During that time, if in atmosphere after rainfall so many droplets exist around earth, what happen here? At that time, small droplets which act as a small prism, the rays of light enter in that droplet, here, to complete 3, that is things, dispersion, then next refractions, and total internal reflection of lights occur. And that's why we see, we appear during that time the formation of rainbow productions. Now, in examinations, give a scientific reason. Some questions also, during that important question, that is, give a scientific reason. Now, in refraction of light, some related questions, that is the first, that is the give a scientific reason, that is the twinkling of a star. Now, star, that is in luminous, star is self-luminous, and those stars, they are, appears, that is the sun. In the absence of sunlight, we know here, the rays of light, that is the star rays of light, they are travels in rarer medium to denser medium. They reaches in atmosphere. What happened here? At that times they enter in rarer to denser medium to change the temperature and density of air. What happened here? Some brightness of star, because those rays of light, that is the real position of star, and this is the apparent position of star. There are the layers of atmosphere. This is the surface, that is the earth surface, and which earth surface, around there are some layer, that is the atmosphere layer. If the rays of light, they are traveling from rarer to denser medium, what happened here? At that time, look here, at that time, they bend towards the normal. Why? Because this is the apparent position to change the density and as well as here the temperature of air. They also change the refractive index of here some medium. At that time here, the brightness of star, this is the real position of star, this is the apparent position of star. If the rays of light, they are enter in atmosphere, what happened here? Those atmospheres, they are change its position. They are changed here temperature and also the density. And that's why here, we know here, at that time, they bend towards the normal. And that's what we feel here. We feel that is they are twinkling of the star. Twinkles म्हणजे चमकणे. लक्षात घ्या, रात्रीच्या वेळी सूर्यप्रकाश नसताना चांदणे आपल्याला लुकलुकले सारखे दिसतात. याचं मुख्य कारण असं आहे, जेव्हा सूर्यप्रकाश नसतो, अगदी निरभ्र संध्याकाळच्या रात्रीच्या वेळी हे चांदणे आपल्याला लुकलुकलेले दिसतात. याचं मुख्य कारण म्हणजे जेव्हा हे चांदण्याचा प्रकाश जेव्हा आपल्या पृथ्वीवर येतो, तेव्हा वातावरणामध्ये हा जो या ठिकाणी हवा आहे, ही जी हवा आहे, याचं जे तापमान आहे, याची जी घनता आहे, हे सतत बदलत आहे. लक्षात घ्या. त्यामुळं त्याचा जो अपवर्तनांक आहे, सगळ्या माध्यमाचा अपवर्तनांक वेगवेगळा आहे. साहजिकच जेव्हा हे प्रकाश किरण, हे रिअल पोझिशन, वास्तव पोझिशन, त्याला वास्तव स्थिती म्हणतात. जेव्हा हे प्रकाश किरण या वातावरणामध्ये जातात, तेव्हा हे प्रकाश किरण वातावरणामध्ये गेल्यानंतर ते बेंड्स टुवर्ड्स द नॉर्मल, म्हणजे ते थोडंसं स्तंभिकेकडे झुकतात. परंतु मूळ स्थिती जर पाहिली तर मूळ स्थिती इथं आहे आणि ॲपरंट म्हणजे आभासी स्थिती हे बघा अशी आहे. म्हणजे दोन्ही स्थितीचा जर आपण व्यवस्थित अभ्यास केला तर आपल्याला ब्राईटनेस, ज्याला आपण ब्राईटनेस ज्याला म्हणतो, म्हणजे हे जे तारे आहेत लुकलुकल्याचं मुख्य कारण म्हणजे प्रकाश किरण माध्यमामध्ये प्रवेश करत असताना स्वतःचा मार्ग बदलतात आणि त्यामुळं that's why we feels here the twinkling of stars. Means they are the position of stars, they are continuously brightening, and also that's why this is also the main important that is changing continuously as star appear to be twinkling. Now next year, during a festival of Holi, what happened here? At that time here, some objects above and below the holy fires, we feel so they are shaking continuously. Here, at that time, if those rays, that is the airs above the holy, holy fires, it becomes hot, and that's why the hot air have a lower density, and also they have lower density, also lower refractive index, and it appears become a rarer medium. Look here, it is a rarer medium. And as compared to cold air have the high density and also here the high temperature. That high density and high refractive index, that's why the rays of lights enter in hot air to cold air. Hot air to cold air. They change its directions. And that's why here we observe, we feel, we appear here. Some objects, they are continuously shaking during a holy fire. Okay. We will see next period.